Yeah, hello and welcome to Gauder Akustik. In this video, I want to tell you something about the technologies and the methods we use for building our loudspeakers, like such a Dark 80. Yes, first of all, we start with the cabinet. The cabinet is one of the most important things for a loudspeaker, and it's really important to have a good cabinet for a good sound. And therefore, we have developed some new technologies in hi-fi. For example, the rib construction system, or the RC technology. You see, a normal loudspeaker is built up of side walls, front baffles, covers and bottom plates. And the problem with this is that all these walls vibrate very heavily if you screw in a driver unit like this one here. So many years ago, we just were aware of the problem, and we thought about building a cabinet of single ribs, like such a rib I have brought with me here. That's a massive aluminum rib cut out of a massive aluminum block. And if you take a look at the speaker, you see how we do it. We just take one rib and stack it one over the other. And the trick now is that we use some damping ribs in between for damping the vibrations. And so this loudspeaker cabinet is absolutely acoustically dead. And so we use diaphragms made of aluminum, ceramics, and diamond. These diaphragms are really light. They're very rigid, stiff, and can be accelerated very hard according to the transients of music. In such a multi-way loudspeaker system, you need a frequency crossover to transfer the frequencies to the right drive unit. And I brought a frequency crossover with me. This is just a frequency crossover of the Dark 100 and for the mid-range only, not for bass or highs. It's just for the mid-range. You see, it's a very complicated circuit and very elaborate frequency crossover. But this is necessary for a good sound, and why this is so essential, I will show you on the whiteboard. So, we check what we call frequency response of a loudspeaker. It's always the same. We have here the amplitude. And here on this x-axis, we have the frequency. So now imagine we have two drive units, for example, the woofer and the mid-range, or the mid-range and the tweeter. And this is just one drive unit. And this is the second one. So in an ideal case, they would be separated very, very sharply like this. So if the mid-range stops, the tweeter starts and vice versa. But in analog passive loudspeaker technology, this is impossible. We can only create loudspeaker filters with orders of 6 dB per octave. For example, loudspeaker filter first order, we have 6 dB per octave. Then this looks like this. Very flat decay. And the according filter, it's not that easy for tweeters, but let's look at this like this. That's a typical curve of a tweeter. And now if we go down minus 10 dB, then we see that it's a big, big frequency range where both drivers are working. So you see, it's a big, big range. And now we have a big problem because we emit the same frequency from two different drivers. Just if we take a look at the Dark 80 here, you see that's the mid-range and the tweeter, and they emit the same frequencies. If you take a look at it, it's a 7-inch, it's a 1-inch. It's a curved and bent diaphragm, and it sits on a different position than the tweeter. And so what arrives at the ear is just a mishmash of frequencies, and so you have a big smearing of the transients, and you lose phase information. Phase information is essential for good spaciousness, for a good stage imaging. And so we just thought of making something different than this normal technology, to have a big separation between tweeter and mid-range with a very high slope. So imagine we have a separation just like this, with a very steep filter for the mid-range and a very steep filter for the tweeter. And now we only have this small area of overlap. And only in this frequency range we have the smearing of transients. So you see, this is a big advantage in contradiction to a filter of 6 dB per octave. What else is essential for this if we use such hard diaphragms like ceramic, aluminum, or diamond? Then we always face the problem that these materials have some bad resonances out of the passband, but they just make distortions and colorations of the sound. And you see, with such a flat filter like 6 dB, these resonances come out very hard, and you can hear them very easily, which sounds really harsh and unpleasant. But if you think of such a filter like we use, then you see these resonances are far away and will not be heard from you, and will not be transmitted by the loudspeaker. This is a big advantage too. So if you want to use such hard and good materials like ceramics, aluminum, or diamond, you have to have such filters of such high slopes. But there is still something more to tell about our frequency crossovers. It's the thing that we call symmetry and symmetric crossovers. It's easy to understand, and I can show it to you on the whiteboard again. So we make a drawing of a systematic setup of frequency crossover and loudspeaker. Here we have a lead, and then as a frequency crossover, we use a very simple now. We just use an inductor, which makes a low pass of first order. And then we have a loudspeaker driver here, just like you're used to. And then we go back with our lead to the amplifier. We set up a voltage from the amplifier, and then just the loudspeaker will play. If you take a look at this, you see two problems. Actually, this is just totally asymmetric, as the frequency crossover is just in the plus lead and not in the minus lead. And you see the ground of the drive unit and the ground of the amp is just the same and connected by the leads. So maybe there can occur some problems, and that's why we thought of doing something totally different now. We just say, okay, what would be if we make a setup like this? We just have the idea to split the crossover in two halves and put one half of the crossover, so in front of the loudspeaker, the plus lead, and the other half here in the ground lead. So here is 1 inductivity, and here's 0.5 inductivity, here 0.52. And now this system is symmetric. And we have disconnected the ground of the drive unit with the ground of the amplifier by a low pass with the half of this. So This is just eliminating a lot of problems which occur when you just connect the groundings of loudspeakers and amplifiers and all the feedback occurring there. And that's the reason why we have so many components here on this frequency crossover for the Dark 100 mid-range. Of course, we have such very steep filters, and these components must be of very, very high quality. That's why we use components of Mundorf and IT Electronics from Germany. You see, there are many new technologies inside our loudspeakers, but you will always ask me, I think it works in studios, but what's in a normal living room? And in normal living rooms, we face the fact that nowadays we use a lot of hard materials like glass, marble, stone, and only a little damping inside. And so we thought of must be a way to adjust our speakers to the acoustical property of your living room. And that's why we have a room equalization system in many of our loudspeakers. Here at the Dark 80, we have the room equalization system on the back of the bottom plate. So please take a look here. You see there is a jumper here and 3 sockets. And with this system, you can adjust the highs. If you take out the jumper, then you have actually position 1, which means plus 1.5 dB. If you put it in like this, in the middle, then you have linear response. And if you take it out and put it in like this, then you have minus 1.5 dB in the highs. And so if you have a reverberant room, this position might be right for you. The same is true for the bass adjustment on the other side. If you take a look here on the other side, we have a bass adjustment system here. If I take out the jumper, then we have a minus 1.5 dB. In this position, we have linear response of the bass. And here, we can increase the bass response by 1.5 dB if you have a big room or if the position of the loudspeaker is far away from the walls in the corner. There are many more details and technologies inside our loudspeakers. You might have seen them on one of our other videos. And if you have not, just to take a look at our Gauder Akustik YouTube channel. There you can find a lot of information. What else is true is that we manufacture everything in-house here in Renningen in Germany. Cabinets, the crossovers, and we do all the design and mounting of these loudspeakers. And so we can give you a 10-year warranty on each loudspeaker we have. So I hope I could give you a little impression in our work, in our manufacturing system. And if you have some more questions or remarks, please do not hesitate to contact me by email, by telephone, or call your local dealer for a demo of this loudspeaker. And I hope to see you again on our Gauder Akustik YouTube channel. Goodbye.